In order to get ready to prepare for finding common denominators work with fractions, you need to understand what prime numbers are and how they work. Essentially, a prime number is a number that will only be divisible by itself. Nothing else can go into it except for 1. So for example, 2 is a prime number. 3 is a prime number. 4 is not a prime number because 2 divides into 4. 5 is a prime number, nothing else goes into it. 6 is not a prime number. 7 is a prime number. 8 is divisible by 2 and 4. It's not prime. 9 is not prime because 3 goes into it. Neither is 10. 11 is prime, nothing else goes into 11. 12 is even, so 6 and 2. 13 is prime. 14 is not. 15 has 5 and 3. 16 is not. 17 is prime. 19 is prime. And there's more. So in order to do a question, to prepare for common denominators, I want you to learn how to do prime factors. Take, for example, the number 48. 48 is not a prime number because it can be broken down. That means that 48 is what we call a composite number. So the way you break 48 down to start doesn't actually matter. You'll always get to the same answer in the end. For example, let's just say I broke down 48 by looking at it as 6 and 8. Well, 6 and 8 is not fully broken down because they can break down further. 6 can break down to 2 and 3, and 8 can break down again. Say you broke it down to 2 and 4. We're still not quite done because 4 can break down again. So we're left with a bunch of prime numbers that all multiply together to give 48. So in the order that I did it, 2 times 3 times 2 times 2 times 2. That can be summarized nice and quick into 2 to the 4th, or 4 factors of 2 times 3. If I took 48 and decided to break it down in a different way, starting, let's just say, with 3 and 16, 2 other factors of 48, the 3 is already done, but 16 is not, of course. Say you did 16 into 4 and 4. Well, that can be broken down again. 4 goes down to 2 and 2. That factor of 4 goes down to 2 and 2. So now you're down to a 3 times 2 times 2 times 2 times 2. Putting them in order from the lowest prime factor to the highest, you would have, again, 2 factors of 4 times 3, which is a shorthand way of writing 2 times 2 times 2 times 2 times 3. And of course, you also could have done, from the very beginning, 48 a different way and done it as 4 times 12. And if you had done it as 4 times 12, you still would have got the same answer, but it would have looked different to start. So you would have had 4 times 12, so 2 and 2, and you would have had 4 and 3, and the 4 would have broken down again, and you would have had a much messier version. But summary would be 2 times 2 times 2 times 2. Basically 4 factors of 2 multiplied by 3. Let me be clear, you do not have to do that same question 3 times. Do it once. Trust your answer. Whichever way you do it, you will always get to the same bottom line. Always. Consider the example of 120. You want to break that down into its prime factors. You could do 6 times 20. You could do 4 times 30, 8 times 15, 10 times 12. It doesn't matter. Pick 2 factors. The easiest way, in my opinion, is to pick 2 factors that are close together. Like picking 60 times 2 wouldn't be very helpful. your tree would be kind of scattered, but if you pick two small numbers like this that are close together, it becomes a little less messy. So 10 breaks down to 2 and 5, and those are both perfectly prime. 12 is 3 and 4, or 6 and 2. Either way, you're not done. 4 has to break down again to 2 and 2. So your bottom line will always be just prime numbers. And then you might want to clean it up and write the first smallest prime number, which is 2. So 2 to the third times 1 factor of a 3 and 1 factor of a 5. 2 to the third is 8. 8 times 3 is 24. Times 5 is 120. So 120 has now been factored into its prime numbers, and that bottom line can be quite useful in another skill later on how to find common denominators. I'll do one more. Let's just take a simple one. 40. So your first job is to find two factors. You could do 8 and 5. You could do 4 and 10. You could do 2 and 20. It doesn't matter. 4 is a 2 times 2. And then your 10 for prime factors is 2 times 5. Put them all together, you have 3 factors of 2 and 1 factor of 5. Double check. 2 to the third is 8 times 5 is 40. That number, 40, which is the composite number, containing lots of prime numbers together, can be written as well as 2 to the third times 5. And this method will be used for finding common denominators. A couple quick hints. Any number that is even is divisible by 2. So if it's even and not a 2, it's going to not be prime. You can break it down. Any number that ends in a 0 or a 5 is divisible by a 5, so it's probably going to be composite. Don't forget to figure out if a number is divisible by 3. There's a little quick test. Say I had a number like 69, and you want to know if that was divisible by 3. There's a quick little thing. You can add those digits together. 6 plus 9 is 15. If 3 goes into 15, then 3 will also go into 69. So divisibility is the key word. And you want to think about divisibility when you're trying to decide if a number is prime or not. If it's divisible, then by another number, it's not prime.